So we have our second question here. Now how do we find the value of this? If you have your laws stated out, the laws I gave you on this side of the board, stated out clearly. Remember that I gave you a law that looks similar to this, that looks something like this. And what do? We can just assign a particular base to both numbers. Are you following me now? We can just assign a particular base to both numbers. Now, if we assign a particular base to both numbers, you have what? This will give us what? No, we cannot use base 5 because they are both having 5 here. Are you following me now? So we can decide to use what? Base 5. So we can assign the same base to both numbers. We can just write what? Log 5 raised to power what? Root 5 over log 5. Log base 5 raised to power 5. Now, there's another law here that says that if the base number and this and its power are equal, this particular logarithm will be equal to what? 1. And look at this one here also. What do? We just change this root 5. If you take note of your indices, root 5 is equal to what? 5 raised to power 1 over 2. If you look at your fractional indices very well, we are sometimes apply some knowledge about indices when we are dealing with logarithmic questions and equations. And so what you have here is what? Log 5 raised to power what? Log base 5 raised to power 5, which is this one, raised to power 1 over 2 now, over log base 5 raised to power 5 raised to power what? Invisible 1, right? Okay, now solving this, what do we get? This one goes to the back, it's still the same thing. Now this one is power, this one will give us what? 1. Now this one will actually give us what? This one over 2 can go to the back. According to one of our laws of indices, clearly stated also, you have 1 over 2 times what? Log 5 power 5. Now this actually gives us what? This one is also equals to what? 1. So we have 1 over 2 times 1 over 1, which will give us what? 1 over 2. Moving further towards this particular question. Now, if you have your chart like I recommended with you should be able to see this already. Now, the root given, the fractional root given is already an indicator to what particular root you should be finding, what particular power you should be finding. Now, to counter this, you will be looking for what? Fourth root of 625 and what? Fourth root of what? 1296. For this, you looking for the cube root of this particular value too. Now, the fourth root of 625 is actually 5, and the fourth root of 1296 is actually what? 6. If you've made your table correctly, you should have that one there. Okay. Now, replace this with what? 5 raised to power 4 over 6 raised to power 4. Which will be equal to what? Sorry, which will be multiplied by, write all this down. This particular cube root affects everything inside here. So you can actually safely say that what? This is 125 p cubed, 2 raised to power minus 3, r raised to power minus 6, raised to power what? 1 over 3. Now, if you continue solving, you have what? This one raised to power minus 1 over 4, right? Now, using your law of indices, you do what? You multiply this power by this power, right? So you have what? 5 raised to power 4 times minus 1 over 4 over 6 raised to power 4 times minus 1 over 4 times 125 is actually what? 5 raised to power 3. You check your table well, like I told you. Whatever fraction, whenever you are saying fractional power or fractional index, you do what? You start finding that particular denominator. Start finding the numbers, the roots, that particular root of the numbers. If it is 3 you are saying, you find the cube root. If it is 5 you are saying, you find what? The fifth root. Are you following me now? And so this will give us what? 5 raised to power 3. Now, all the values will be multiplied by this power. Every single one. So that 5 raised to power 3 times what? 1 over 3. 3 raised to power what? 3 times 1 over 3. 3 raised to power what? Minus 3 times 1 over 3. And you have r raised to power what? Minus 6 times 1 over 3. Now this will actually give us what? 5 raised to power minus 1 over 6 raised power minus 1 times what? 5 raised power what? 5 raised power 1, right? 2 raised power what? 1, abi? 2 raised power minus 1. And r raised power what? Minus 2. Now if you are going to before you multiply this, take note of this symbol here. This is the same thing as saying what? 5 over 6 r raised power what? Minus 1, right? Times 5 p raised power minus 1 r raised power minus 2. Now this is actually equals to what? 1. This is actually equals to 1 over this. Now this will give us what? The reciprocal of this will give us 6 over 5 times 5 pq raised power minus 1 r raised power minus 2. This is what? 6 over 5 times 5p. Now 2 raised power minus 1 is what? Over q. So it will be what? Over r squared. Now this will cancel this. You have 6p over qr squared as the final answer. Quite simple, right? Now we'll be solving our last questions, one for logarithm and one for indices. Now while solving this particular question, I plan to deal with a particular challenge that most students have in indices and in logarithm. Now looking at indices here, how that this particular one does not have the same common base value with this. So how do we make them have the same base value? Because if it was something like 2 raised power 2x is equals to 4, something like this now is quite easy for you, right? You just write this to be what? 2 raised power 2x is equals to 2 raised power 2, right? And then you just cut through like this, and you have 2x is equals to 2, then x is equals to 1. But now that you have 1 here, 1 cannot become, are you getting me? It cannot become a number with a what? Base value of 2, naturally like that. But there's a law of indices that we can take advantage of to find a common ground between them. Same thing here. This number has no logarithm behind it. It has no base value behind it. So how do we find a common ground between these two so we can find an answer? Okay, very quickly. Looking at this one, first of all, there's a law that I gave you in your logarithm and I told you to take note of, which is what? Log a power a is equals to 1. Now, look at this particular logarithm here. What is the base value here? That's the first question you should ask yourself. The base value here is what? 25. Now, we can actually safely say log 25 raised power 25 is equals to 1. Yes, according to this law now, is equals to what? 1. As long as the base value and this value is equals to I equal, the logarithm of this will be equals to what? 1. Now, we have 2 here, not 1. So we can now safely say that 2 times what? Times all this, which is 2 times log 25 raised power 25 is equals to what? 2, right? Now, replace this one with this. You would have what? 2 log 25 power 25 minus log 25 raised power 5. Now, it's making sense now, Abby? Okay. Look at this now. You have this one becomes the power for this one. Another law of logarithm. So you have log base 25 raised power 25 raised to power 2 minus logarithm of what? 25 raised power what? 5. Okay. Now you have what? Log base 25. 25 squared is what? 625 minus logarithm of what? 25 raised power 5. Applying this, you have what? Logarithm of 25 raised power 625 divided by 5. This will actually give us what? Logarithm of 25 raised power what? 125 raised power 125. Now, 125 as a number is actually log what? is actually 25 raised to power 3 divided by 2. 25 raised to power 3 is what? Okay. This gives us log 25 raised to power 25 raised to power 2, right? Minus, now 5 related to 25. 5 is actually the square root of what? 25, right? Now square root of 25 can also be written as what? 25 raised to power 1 over 2. So just write raised to power 25 raised to power 1 over 2. This is same thing as this same way you can write 5. Another way you can write 5. Now we now have two log what? 25 raised to power 25 minus log 25 raised to power what? 25, but here you put your half here. Now this one is power, this one is equal to 1, this one is power, this one is equal to what? 1. You have 2 minus 1 over 2, which is what? 1 over 1 over 2 as your final answer for this one. And moving towards logarithm, moving towards indices, here, how do you find a common graph? Take notes. A raised to power 0 is equal to 1. We can always change this 1 to what? 2 raised to power 0 is equal to what? 1. So you have 2 raised to power what? 2x squared plus 15x plus 7 is equal to what? 2 raised to power 0. This cancels this one out. You have 2x squared plus 15x plus 7 is equal to what? 0. Very quickly, what do? Let's factorize this. But we multiply a and c together first. 7 times 2 is what? 14. Now, what times what will give you 14? Plus, and you add together, that will give us what? 15. That's 14 and 1 plus 14 plus 1. So you have 2x squared plus 14x plus x plus 7 is equal to what? 0. Now what's common between them? 2x, x plus 7 plus 1, x plus 7 is equal to 0. 2x plus 1, x plus 7 is equal to 0. 2x plus 1 is equal to 0, and x plus 7 is equal to 0. Now you have 2x is equal to what? Minus 1, and x is equal to minus 7. X is equal to minus 1 over 2, and x equals to minus 7 as your final answer to this question. Now we've come to the end of the class. Do well to subscribe if you have not subscribed to our class before, and we hope to make much progress together. Have a nice day.